If you've already spent a year or two with SolidWorks, fully defining sketches is probably second nature by now. And you're likely already using some of the common interface tricks to speed up the process, such as inference lines, context menu shortcuts, etc. And while we typically recommend defining a sketch as you're creating it, that's not always an option, and fully defining large or complex sketches from scratch can be painfully slow. For example, maybe you need to edit a sketch that you yourself didn't create, and the original author wasn't quite up to speed with the fundamentals of sketching. Another example we commonly see in industry is the need to import a DWG or a DXF drawing and convert it from 2D to 3D, which typically results in a lot of undefined sketch entities. Fortunately, there's one very powerful tool that can speed this process up dramatically, but with great power comes great responsibility. We'll be showing you how to create hundreds of constraints and fully define a sketch in just 3 clicks using the fully defined sketch tool, and also explaining why you might not want to do that in today's Ask SolidProfessor. Here, just not like
here.
that.
You gotta
Try turning it off and back on again. Here, try this. No, there we go. That wasn't too bad. To begin, I'd like to mention that the fully defined sketch tool is not recommended for beginners and should really only be used once you have a strong understanding of sketching fundamentals and design intent. For a quick refresher, check out our video titled Determining Why a Sketch is Underdefined in the Ask SolidProfessor series, or take a look at our Introduction to SolidWorks course for a more comprehensive overview. Now we're actually going to start off with a bad example in this video, as there's a lot of ways to use fully defined sketch incorrectly or inefficiently, and some situations where it won't work no matter what you do, and this can lead to a lot of frustration. It's important to remember that fully defined sketch is not as smart as you, and it shouldn't be used unless you already understand your required design intent. This is a layout sketch representing the front view of an office desk, and while it's not terribly complex, you can see there isn't a single relation or dimension present, so we're starting from scratch here. But most importantly, it's a bad sketch. So what do I mean by this? If you take a closer look at the geometry, you'll see that several line segments are disconnected, some segments are angled when they're clearly supposed to be horizontal, we have obvious missing tangent relations, circles of different sizes that are clearly supposed to be equal. The whole thing is just a mess. And this is really important because the fully defined sketch tool is going to make inferences about which types of relations and dimensions it should add based on the settings we use, but also based on the condition of the geometry we're working with. For example, if it recognizes that a line happens to be horizontal, it'll add a horizontal relation. If it recognizes multiple arcs or circles of the same size, it'll apply an equal relation to them and even give them a shared dimension. If it doesn't recognize any nice clean sketch relations to apply, the result is often a mess of dimensions that don't make any sense. My point is, we would need to fix these outstanding issues first if we want fully defined sketch to work as well as possible. Though you can still use it on bad geometry, you're going to be doing a lot more cleanup after the fact and likely defeating the purpose of the tool. Let's make a quick comparison. From the Sketch tab, I'll click the arrow under Display Delete Relations and activate Fully Defined Sketch. We'll dig into the options in a bit, but for now, I'm going to leave everything set to default and just click Calculate. And by the way, you do need to click Calculate before clicking OK in this command, otherwise nothing will happen. Notice how many dimensions and relations appear on the screen. Sure, the sketch is technically fully defined, but at what cost? What kind of intelligent design intent could this sketch possibly have? Looking closer at the arc on the upper left, no tangency was added, and as we look at what was supposed to be a pattern of circles centered on this construction line, we instead see a variety of different sizes, and the circles aren't even attached to the construction line. There's a lot of other issues in this sketch as well. I have another file here that's nearly identical except that it's much cleaner. Still no relations or dimensions, but the lines are connected, arcs are showing tangency, and the circles are all lined up and equal in size. Now you may be asking yourself, wouldn't all these relations be captured automatically during the sketching process? And generally you would be correct if the sketch was created from the ground up in SolidWorks. But if you imported the sketch from another source, or converted it from the geometry of a solid model, for example, you could easily end up in a situation like this. But let's see how fully defined sketch behaves now. Same process as before, but with wildly different results. The dimensions still look a bit messy, and we'll address that in a moment, but let's take a closer look, starting with the arc. We can see 2 tangency relations along with an equal relation and even a shared dimension have been added, indicating that the tool has even recognized the identical mirrored geometry on the opposite side of the sketch. Likewise, all 14 circles have been set equal and attached with coincident relations to the construction line. Now, I want to be clear, this still isn't perfect, as there are a few pieces of design intent here that don't really make much sense. For example, the height of the horizontal support across the center of the desk is dimensioned using 2 baseline dimensions from the origin. We can easily adjust this by removing the 165mm dimension and replacing it, but these are the types of things you'll need to look out for, and should expect to spend a bit of time correcting. I should also point out that because of how I set up this example, all the dimension values have come out nice and round. In practice, you'll likely need to make some adjustments to dimension values. Next, I want to talk about the options available within Fully Defined Sketch and see if we can't clean these dimensions up a bit while we're at it. I'll undo back to the undefined sketch and run the command again. First, we have a section labeled Entities to Fully Define. You'll likely be tempted to leave this set to all entities, but especially for large sketches, selected entities is often the best choice. Selected entities allows you to specify which parts of the sketch you'd like to fully define, as opposed to trying to force the same options to work on the entire sketch all at once. Let's use our pattern of circles as an example. With the field under Selected Entities activated, I'll select all the circles. Next, I need to take a moment to think about which types of relations I want the tool to apply to the circles. If enabled, the Relations section allows you to choose which types of relations will be added and which will not be added, giving you quite a bit of control. If disabled, only dimensions will be applied. For example, if I were to click the symbol for the equal relation to disable it, the result would be a unique diameter dimension for each individual circle. This obviously isn't what I want, so I'll turn the equal relation back on and click Calculate once again. That's another important point too. If you want to try out different sets of options, you can use the Calculate button as many times as you would like before clicking OK. And there's also an undo command built into the property manager for your convenience. Be aware though, if you want to see relation symbols as you use the tool, make sure they're enabled before you run the command, as you can't turn them on or off while it's active. When it comes to dimensions, we have a few options for both horizontal and vertical dimensions. The options are the same but can be controlled separately. First, I need to choose a scheme, and we're currently looking at a baseline scheme for the vertical dimensions, where everything attaches to the same point. The chain scheme bases each dimension off of the previous entity, and ordinate dimensions are similar to baseline, but are organized and managed a bit differently. Notice how much cleaner the result is. The result is a nice set of dimensions, along with horizontal, vertical, and equal relations that all make sense. You'll notice our bottom dimensions are repeated on the left and right sides. One limitation of Fully Defined Sketch is that it cannot automate symmetric relations, so you may need to add them afterward if necessary. Using Selected Entities mode provides a nice middle ground between the glacial pace of defining everything manually and the lack of control when defining all entities at once. I'll repeat this process for the upper geometry, and it works pretty well, but you'll notice one line remains underdefined. If I want to fully define this line segment, I'll need to be sure to include the vertical lines I intend for it to attach to, and then it works as expected. You'll notice that so far everything has been dimensioned from the origin, but this isn't a requirement. For the feed to the desk, I'll select all the entities as usual, and then look for the pink and purple fields available in the Dimensions section. Here you can set the origin for horizontal and vertical dimensions independently. In this case, I'll choose the bottom right corner of the foot profile for both, and additionally use the dimension placement options to ensure the dimensions appear in the proper position relative to the sketch. Notice how these dimensions refer to the point we selected on the rectangular profile rather than the origin. This can be extremely helpful when working with sketch entities that are intended to refer to other portions of the sketch. Lastly, we'll run the command a final time for the remaining geometry and then begin investigating for anything we've missed and any not so good design intent. You can always check the feature tree to tell if your sketch is fully defined. If you see a dash in parentheses next to the sketch name, the sketch is underdefined, but keep in mind that you may need to rebuild to update this status. Right away, I see a few entities that I've missed in blue, and I can quickly apply some relations to make the sketch fully defined. From here, a bit of dimension replacement and cleanup, and perhaps a symmetric relation to better organize the right side of the sketch, and I'd be good to go. It's always a good idea to check the design intent of key features after using Fully Defined Sketch. So hopefully, those examples have helped you to understand how Fully Defined Sketch can help you quickly define complicated sketches, but remember, it only works if your geometry is decent to begin with, and you already have a solid understanding of what you're trying to accomplish. I have one more example before we wrap up for those of you who work with imported drawings, particularly DWG and DXF files. Oftentimes when importing a 2D drawing into SolidWorks, the resulting geometry is pretty good but may lack constraints and sometimes appears offset from the origin. Here I'm importing a DWG to a SolidWorks sketch, making sure to only import the layers containing geometry and disabling the reference sketch option to make sure I can modify it. You'll notice there's also an option here to import constraints and dimensions, and you can certainly try using this, but I found the results to be rather inconsistent. So assuming the drawing imports with no constraints, what do we do? First, notice that the sketch is completely disconnected from the origin. If I try to drag any portion of the sketch geometry to connect it, it just distorts because there's no constraints. To work around this, I'll run the fully defined sketch command as is and simply set the origin for the dimensions to where I ultimately want the origin to be. In this case, I'll use the bottom left corner. A warning appears when I click calculate telling us the sketch is still underdefined, but this is to be expected since we're not using the sketch origin to define our dimensions. I'll click OK, and now, since all the sketch entities are related to one another, I'm free to drag the sketch onto the origin as I see fit without any distortion, and the sketch is fully defined. Now you may wish to review the results for design intent, but often with imported legacy files like this, the goal is simply to reproduce a 3D model of the correct shape and size without worrying about design intent. If that's the case, just check the unit system, take a couple measurements to verify critical dimensions, and get started on creating some features. But if you do need to make adjustments to design intent, now you have the tools to do so. So, now that you've seen the fully defined sketch tool in action, I hope you'll be able to use it to speed up your work with complex sketches, imported drawings, or even simple drawings. If you learned something today, do me a huge favor and give this video a like so others can find it as well, and consider subscribing to the channel for weekly CAD tips and tricks. If you'd like to learn more about the powerful sketch tools and workflows that the experts are using, be sure to check out our SolidWorks Advanced Sketching Techniques course over at SolidProfessor.com, where we cover everything you could possibly want to know about sketching, from derived sketches to splitting entities to 3D sketching techniques and more. Thanks for watching, and see you next time.